Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on lines and circles. Let's take a look at a few theorems and some example problems with the theorems that are going to discuss this idea of lines and circles. First theorem that we have here is the measure of an angle formed by two secants that intersect in the exterior of a circle is 1/2 the difference of the measures of the intercepted arcs. So here's a picture of what this theorem is talking about. If I have two secant lines will intersect a circle in 2 points. So you have line AC intersects a circle at A and C, line BD intersects a circle at points B and D, and you got this angle 1 is formed there. That angle is going to be equal to 1/2 of whatever the intercepted arc is from AB, so from here to here, minus the intercepted arc from here to here, C to D. So if you know these intercepted arc regions, the degrees of them, then if you take the difference of them and multiply it by 1/2, then you'll know the angle for angle 1. Now, because 1 and let's just say I put a 2 here, those two angles would be congruent to each other because those are vertical angles. So if you know what 1 is, then you know what 2 is. But if you know what arc AB and arc CD is, just subtract the 2 and multiply by 1/2, then you know what the angle. Let's take a look at an example. In this particular example, I have the angle of 36, but what I don't have is the smaller intercepted arc. So the formula still works out the same, the theorem works out the same. The measure of this angle, which in this case is going to be equal to 36, so I could just write it like this. I could say 36 degrees is going to be equal to 1/2 of the intercepted arc, the larger intercepted arc, which is going to be 86, minus the smaller one, which is going to be x in this case. Now, doing a little bit of algebra, solve for x, and I'll know what that missing intercepted arc is. So 36 is equal to 1/2 of 86, which is 43 minus 1/2 x. Subtract 43 from both sides. And coming over here, I get negative 1/2 x is equal to negative 7 degrees. Multiply everything by negative 2. And that gets rid of that, so x is equal to 14. So x, this intercepted arc from here to here, must be 14. Now let's just think about it. 86 minus 14 is 72. And 1/2 of 72 is 36. So here's an example with this first theorem. Another theorem is the measure of an angle formed by two secants that intersect in the interior of a circle is 1/2 the sum of the measures of the intercepted arcs. So here's a drawing of it. I have a circle here. I have two secant lines. It intersects a circle in 2 different points. I have secant line AE. A and E are the points on the circle. Secant line BD, secant points B and D. They intersect this time in the interior of the circle. Last theorem was on the exterior. Now, the measure then of this angle 1, and also if you thought about angle 2, since they're vertical angles, is going to be equal to 1/2. So the measure of angle 1 is going to be 1/2 the sum of the intercepted arcs. So you got arc AB plus arc DE. And these are the arcs that are formed from the secant lines. All right. So if you add the two intercepted arcs and then take half of it, that would give you angle 1. Let's take a look at an example problem. So here I have two secant lines, and I'm asked to find the measure of that angle. So according to the theorem, the measure of this angle is going to be equal to 1/2 of the two intercepted arcs added together. So 82 plus 74. Now, 82 plus 74 is 156. So x is equal to 1/2 of 156. And that would be 78 degrees. So here is a second theorem using secant lines. This one's on the interior. Another theorem states that the measure of an angle formed by a secant and a tangent, or a tangent and a secant, that intersects at the point of tangency is 1/2 the measures of the intercepted arc. So a picture would be, you have a tangent line which intersects a circle in 1 point and a secant line which intersects a circle in 2 points. And we have this angle 1 that's formed. The measure of angle 1 is going to be equal to 1/2 of its intercepted arc. So in this case, 1/2 of arc AB. Let's take a look at an example problem. So if I have a circle with a tangent and a secant, they intersect at the point of tangency. So at that point right here on the circle, what is the measure of that angle? Well, it's going to be equal to 1/2 of its intercepted arc. So from here all the way around to here. Now if the intercepted arc is 214, half of 214 is 107. So that angle would be 107 degrees. Another theorem that I have would be the measure of an angle formed by a secant and a tangent that intersects in the exterior of a circle is 1/2 the difference of the measures of the intercepted arcs. So looking at a picture of it right here, a secant line BC and a tangent line AD perhaps, then the measure of angle 1 is going to be equal to 1/2 the difference of their intercepted arcs. So the bigger intercepted arc is out here in front, arc AB, minus this other one right here, arc AC. Again, notice that there's a common theme here with lines and circles. So far all these formulas contain the number 1/2, and many of them deal with arcs or intercepted arcs, and the majority of them are going to deal with the difference of intercepted arcs. Let's take a look at an example of this type of problem. Here's an example. Have a secant line AD, or a tangent line AD intersects a circle in 1 point, and a secant line BC intersects a circle in 2 points. Now, my angle X that I'm trying to find is going to be equal to 1/2 the difference of the two intercepted arcs. The only problem is I don't know what this intercepted arc is, AB. I know what arc AC is. So X is going to be equal to 1/2 of arc AB, which I don't know, minus arc AC, which is 124. Now, I can't have two unknowns, but this 76 is going to help me. We know that from here all the way to here is 76. And 76 plus this part, 124, is equal to exactly 200. Now, the circle has 360 degrees, so then if that part is 200, then this part must be 160. So my missing part is 160. So 160 minus 124 is 44, and 1/2 of 44 is equal to 22 degrees. And I just looked back on my calculations, and I'm a little bit wrong there, so sorry about that. So I have X is equal to 1/2 of 160 minus 124 is actually 36, not 44, my fault. So X is equal to 18 degrees. All right, 18 degrees. My last theorem for this video is the measure of an angle formed by the intersection of two tangents is 1/2 the difference of the measures of the intercepted arcs. So a little picture of this might be, I have two tangent lines, and I'm trying to figure out the measure of angle 1. It's going to be equal to 1/2 the difference of the bigger major arc, so arc ACB, minus the smaller one, just AB. Let's take a look at an example. So in this one, X is going to be equal to 1/2 the bigger intercepted arc minus the smaller intercepted arc. So X is equal to 1/2 of 136, so X is equal to 68 degrees. Thank you for watching. God bless.